Hello everyone, welcome to AI Anytime channel. In this video, we are going to look at Meditron 7B LLM. It's a new large language model which has been, built on the medical domain, and it has been fine-tuned using Llama 2 7B. And that's what we're going to look at in this video. And we also see if we can use this model for a healthcare or a medical based RAG use case. Now, where you have n number of documents or data or information, and you want to use this LLM to see if this improves the retrieval augmented generation process that we have, earlier used for a lot of different use cases. That's the agenda of this video. Now, uh, it's a gated model. So if you are coming on the Hugging Face for the first time, you have to just accept the like terms, criteria, or whatever that they have here. You can see I have granted access to this model because I have selected the checkbox. Now, it has been developed by EPFL. You can find it out over here. It's been trained on, data. You can find it out below. Let me show that quickly, and you can find out the data sets which has been evaluated and trained on different benchmarks and data sets. You can find out the categories here like clinical guidelines, medical paper abstracts, 16.1 million abstracts extracted from PubMed and PubMed central papers, and then medical papers, replay data, etc. Now, this is not the first medical related LLMs. There have been a couple of other LLMs as well for, of this scale that we have seen in the healthcare industry or the medical domain. Now, very honestly, not a good model, by the way. Meditron is not a good model for RAG kind of an implementation, and they also say it here. If you come down, somewhere I was reading that they don't recommend this for production, of course, and it's not working good. I will show you a couple of examples. The whole reason of creating this video is that there were a few requests of covering Meditron 7B LLM. And every time there's a new LLM, there have been some requests. Now, for this, I'll take a different approach altogether. When we are building the RAG, I'm not gonna use a BGE embedding model or MPNet or mini LM or multilingual E5. I'm not going to use general purpose embedding models. As we are looking at a medical use case, I'm going to use a medical based embedding model, which is again called as PubMed based embedding. So if you read here, it says this is a PubMed based model fine tuned using sentence transformers, of course. It maps sentences and paragraphs, and the vector space you can find it out is 768 as a dimensional dense vector space, and can be used for tasks like clustering or semantic search. So we're gonna show our interest in semantic search in a bit. Now, the training data set was generated using a random sample of PubMed title abstract pairs along with similar title pairs. Now, this is interesting because if you look at Meditron as well, most of their training corpus have been originated from PubMed abstracts and related, other journals or medical literatures, mediums, etc. And this can be a powerful combination when you want to build a domain specific RAG. You have to look at end to end everything domain specific. Look at your data which is domain specific like medical. Then look at an embedding also which is medical specific like PubMed, for example. PubMedBERT, by the way, sorry, PubMedBERT base as an example. You do not use a general purpose embedding model because again it boils down to weights. Everything that we do in artificial intelligence boils down to the weights and how the weights have been adjusted, or weights have been defined. Of course, when you use neural networks, etc., you'll understand that in detail, but this is how it works, guys. So in this case, we'll start with a medical document as a data source, couple of documents. Then we'll create embeddings of PubMed bot based embeddings. Then we'll store that in QDRAND. We're not going to use in-memory vector store. We're going to use self-hosted vector databases like QDRAND, Waviate, or Milverse. So for this video, I'm going to rely on QDRAND, where I will run that within a Docker container, and I'll explain that how it works. And then we'll use large language model Meditron 7B to retrieve some kind of information through a generation steps, of course. Now let's start building the application, guys. And what I'm going to do is I already have a folder here called medrag, and I'm just going to open in new terminal. You can see I have a virtual environment already, but I will just open this in code dot, and here you can find out all the requirements. So we need torch, we need sentence transformers, LangChain, fast API because we're going to build a conversational kind of an interface or a simple question answering interface. We'll see that. Then we have UVCon, so web server to run the fast API app. Then we have couple of PDF doc libraries like PyPDF2, etc. Jinja 2, which is a template for the front end that you can use it with fast API, Flask, etc. Then we have, I don't need Chroma here. Let me just remove that. We're going to rely on QDrant. So I'm using QDrant client. And then we need C transformers that helps you load the GGUF model that we're going to rely on. And then we have Python multipart and AIO files for fast API file uploads and formatting, etc. Now, let's create a file called ingest.py, and then I'll show you what data that I have. If you come here on the data folder, you will see that we have couple of documents. Both I have downloaded from PubMed again. Now, one is Medical Oncology. It's a medical oncology handbook for junior medical officers. It has 50 plus pages. You can find out, it's related to basically oncology, which is cancer, etc., right? And you can find out principles of cancer immunotherapy, topics like different topics you can find out here. Chemotherapy abbreviations, these are the like what is TAC means, what is TPF means, and all those things. And then you have medical oncology emergencies, cancers of gastrointestinal, etc. Right? So basically, it's a document related to oncology. If you are a radiologist, or oncologist or a doctor, you would have been having interest in building, this kind of systems where you can retrieve information faster or search. Now, the other one is kind of a medical literature. It's a review article. It's called Cancer and Cure, a critical analysis. It has some abstract. It's kind of a paper. Then we have introduction. Then we have multidisciplinary aspects, and then we have conclusion, etc. Now, few pages, 2 or 3 pages. So we have couple of documents. You can put n number of documents here. It doesn't matter because now we are gonna use a self-hosted vector database. It's not a in memory that will give you basically memory index out of error or memory out of error kind of a thing, right? So now how do we do that, guys? So I'll show you. Let me just close this. Now in ingest.py, let's store. So I'm going to use LangChain as an orchestration framework. You can use Llama index, semantic kernel, etc. as well. Now from LangChain dot text splitter, we're going to split the text. So text splitter import recursive character text splitter. So this is what we need, recursive character text splitter. And then from LangChain dot vector store, let's, oh, we don't need Chroma now. So we'll just import it through QDrant. Okay. Now we need the PyPDF thingy, so directory loader and also from LangChain dot document loaders, and here we want to import uh, directory loader because we have a directory and we are loading our file from the directory. Now here are a lot of tricks that you can use when you are working on chunking strategies. You can use unstructured library if you have a lot of unstructured kind of documents like PPT or Word files. Unstructured helps you extract text in a better way, and you can do that. Now what I'm going to do here is from LangChain dot document loaders import PyPDF loader, and then the next is from LangChain dot vector store, let's import QDrant. We'll see. Now I think this, okay, we need the embeddings model. So from LangChain dot embeddings, of course, I'm going to import sentence transformer because I'm going to load that from sentence transformer embeddings. Sentence transformers embeddings. Perfect. It's not transformers, sentence transformer. Okay, this looks good. Now we are okay with our import. The next thing that we're going to do is I'm going to create a variable called embeddings, which will hold my embedding model. Okay, so for that sentence transformer, and here you can pass the Hugging Face repository name of embedding model that we're gonna use. Now model name, let's go back to the GitHub, not GitHub by the way, excuse me, sorry, it's the Hugging Face repository, and let's come here and put it there. Now you can look at I'm using by new ML. If you don't know what new ML is, by the way, I just I recalled it. So new ML has created text AI. It's a library TXT AI. So which helps you with natural language processing task, semantic search, different entity recognition kind of a task. So new ML is like an I don't know I if it's in closed source or it's like basically the library is open source, but they also have some cloud-based services as well. So it's kind see this as an organization. Okay, so they you can find it on the GitHub repository or where they have created TXT AI, text AI, which is really good when it comes to performing tasks like semantic search, entity recognitions, etc., etc. Now that's the one who have hosted this on Hugging Face, and that's the embedding we're using. Now let's print the embedding and see what's inside that. Okay, print embeddings. Now this is fine. Now next is loader. So loader equals directory loader, and here so directory loader, and I'm gonna use my okay, it's caps data. So data, and then after data we can define globe basically where we can pass our like we are looking at the PDF basically. So let's pass that. You can do markdown, CSV, anything you want. Okay, PDF. Now these let's have a show progress that can help us track in the terminal how it's going on. Show progress equals to true, which is a boolean value. Now uh let's give loader class. Which library to use by the way to load and extract loader CLS. Okay, loader CLS would be PyPDF loader. Okay, fine. We are okay with loader now. So documents and documents equals loader.load, and then we're gonna load this. Now text splitter, we are gonna use recursive character text splitter. So recursive character text splitter, you can define chunk size, etc. So my chunk size is gonna be 1000, and then I have a chunk overlap. Okay, if you have good compute power, keep a chunk size higher. It's a very intuitive topic. Chunk overlap equals 100. Now 1/10 of chunk size should be your overlap. That's what they recommend. Now let's have a text equals text splitter dot split document. So text splitter dot split document, that will help you split. It's a Python list by the way that it will get in the end. Split documents, and here you pass your documents. Perfect. Now we have the text now. Okay, cool. The next thing that we're gonna do is now the QDRAN thing, guys. You know what I'm gonna show you is I'm gonna open my terminal here and we'll see if Docker is running. So I have Docker installed in my machine. It's Docker is a container technology, by the way, that helps you with a lot of things. Where if you are working in a large software projects, technologies like Docker or the container technologies really helps you with versions, conflicts, dependencies, and it also helps. It's like it's a different topic. I have covered a lot in my previous videos. You can watch out. I have videos on Docker as well in my AI deployment series. You can check that out. But what I'm going to show you is, let me see if I have the QDRANT image. So you can see I have something called QDRANT. When I run the command docker images, that helps you find out if you have any image. If you don't, so first of thing, if you are using Linux, it's very easy to install Docker with sudo command. You can install Docker and create a user group and set that. Now in Windows also you can download the exe Docker desktop and you can download like that, and you can also download through command line. Now I already have Docker installed, so I'm not covering that. Now once you have Docker installed, you have to come and check Docker images. If you don't see anything, then you have to just do Docker pull, and then you can do the image name. So you can see this is the image name, official image name, which has been hosted on Docker Hub official repository. It's hub.docker.com or org, whatever. Now this is how you pull a Docker image. Now once you have the Docker image, what you have to do now is, let me see, I already have that command with me, so I'll just do, you can see I'm running Docker. Now I'll just do docker run -p, which is defining the port. Now as I said, it's a self-hosted vector database. You have to run this on a port. Now this particular thingy runs on port 6333. You can also run it on the respective port on 6333 as well. You can run it on 63334 as well. Now you can also define volumes. Now you can find that in the QDRAN documentation. I will give the link in the description if you want to really go deeper into it. But once you run this, you will say access web UI at localhost this. Now let me go back, and what I want to show you is, let me open my YouTube and I will show you. I have a very detailed video, on QDRAN. Let me go here and show you that. And I'm gonna go on content, playlist. I have a beginner series or something like that. Okay, now here, if you come here, okay, not this. Let me go to videos. I have, you can see here, get started with, and let me open in YouTube. This is the video I'm talking about, guys. You can look at this video if you really want to learn vector database from scratch. QDRAN vector database, build your first RAG. And that's in this video I have shown completely from scratch how you can use, install, etc. In that, so you can figure out from this if you are facing any errors as well related to this. Now I'll give the link of this video in description. Now coming back to this, you can find out it says localhost 6333. So let's open that. So localhost. Okay, I'm not getting anything like that, but it's fine. Now you will get it. Now you open dashboard, you will see something called collections, and it says no collection is present. It means I don't have any vector database created yet. Let's create something, guys. So for that, what I'm gonna do is I'm gonna create a vector database here. So for that, uh, let's first you have to define the URL. So my URL is, let's get the URL from here. Okay, so let's get this. Control C thingy, and then here you have to put HTTP because it runs on HTTP. Okay, I already have HTTP there once I copied it, so this is fine. Now this is your URL, and in this URL we have a QDRAN vector database running, and we'll store that there. So let's do that. Now I'm gonna do QDRAN equals, here I'm gonna use QDRAN dot from documents. If you use Chroma, you also do Chroma dot from documents. You use Files, you also do Files dot from documents. So same thing, the taxonomy is same. So from documents, and here I'm going to pass my text, and I already have the embeddings model. So embeddings, and here I'm going to pass URL equals to URL. I'm telling that QDRAN variable that, hey, look, you have to store there the embeddings in the URL which is running. Now after that, we have something called gRPC, okay, which is a remote protocol. It's if I'm not going to detail into that because in that video I have captured this as well, the video that I was showing you. Now prefer gRPC, let's keep it false. And then collection name, so you have to define a collection name. What should be the name of your vector database? So let's, for example, let's call this vector score underscore database. Fine. Now this is my QDRAN. Now I'm just going to do print vector database is, excuse me, is created, something like this. Okay, now this is the code to create embeddings out of your directory, the documents that you have. And now let's run this, guys. So what I'm going to do here is here where I was running, basically not here I have to first activate my, not virtual environment. So let's do that, scripts, and then dot slash activate, couple of cd dot dot clean, and then you do python ingest.py. It says cannot import name recursive. Okay, it should be recursive character text splitter. This is so bad. Recursive character text splitter, and this will also become then recursive character text splitter. Now let's see that if you are still getting the error here, guys. Okay, now you can see my Docker is running, so do not have to do anything with that. Let's that uh, up and running there. Okay. You can see the model name. So our model name is new ML PubMedBERT based embeddings. It's a medical specific embedding model. So I'm not using a general purpose. Now, if you are building something for lawyers or for law or the law enforcement agencies, anything legal, you can also use legal BERT kind of embeddings model. There are a lot of models available for different use cases. You have insurance based embeddings model. Now that helps you because they have seen that in their training corpus, right? Those kind of terminologies. So once the model were being created, they would have seen that, and that's the way weight would have been assigned on them, right? And once you now build something very domain specific, it helps you, while we do the semantic search, it might improve the performances. That we can check it out. Now if you look at here, it says vector database is created. Come back here in the dashboard, hit enter, and you'll see something called vector database. You can create n number of vector databases here. Now if you click here, it will open and it will show you some info. You can find out that the status is green. On our document, we had 115 vectors and the chunk size was 1000, by the way. You have to remember that. Now, it gives you some information on the configs, on the schemas, etc. You can also visualize it if you want. You also have snapshots. You also have points. On the points you'll find out all the different 115 vectors that you have, the vectors count. You can find out the metadata for that. The source and page are your metadata, and that where we use LangChain retrieval QA chain with source document, and this basically, we retrieve this. So that's where the metadata is there. Then you find out your page content, the default vector size, which is 768 as a dimension I'm talking about. Now you have metadata again. You can find it out here, right? So self-hosted vector database, do not have to rely on Chroma, Fast, etc. Those are not scalable. Those are not that good. So you can see it. We have QDrant here now up and running. Let's build create a file called retriever. So I'm going to create a file retriever.py. Now in the retriever.py, now what I'm going to do is I'm going to use that created embedding model and see if I'm able to retrieve first the semantic search. Okay, let's copy few things, guys, from here. I'll type it faster. Now from langchain dot vector store, and the vector store you will be your qdrant. So import qdrant again. Let's get qdrant. So qdrant is done. Now we need the embedding again. So from langchain dot embeddings, I think it was sentence transformer. So let's get sentence transformer embeddings, and then from langchain dot, not langchain. Now let's load it from qdrant client. So from, excuse me, from qdrant client, import qdrant client. Fantastic. Now let's copy the embeddings name here. This big thingy, embeddings variable. Let's copy it, paste it over here, and the next thing is I'm gonna have a client here. So client equals qdrant client, and inside this I'm gonna pass couple of things. The one is the URL. So URL is equals URL. I have to define that URL. I forgot that, but we'll do it. Now URL equals URL, and then prefer gRPC again equals false. You are building it in production, make sure you keep it true. It helps you. Please watch that previous video to understand what gRPC role is. Now URL equals, let's get that URL from here, by the way. Okay, I get it. Let's paste it here, and client queued. And now the next thing is, let's print the client thing. So print client, and now db, so or a db variable that will help you with. And now let's use langchain qdrant class. Inside qdrant I'm going to use client equals client, and then embeddings equals embeddings, and then have a collection name defined. So we have a defined name which is vector database. This is our collection name that we created, and that collection name you will get it from here, guys. Look at this. This is your collection name. So vector database is done. Now the next is, let's print db. Let's also have some kind of separation, something like that, or slash n or something. Okay, print is done. Now let's have a query. So my query, I already have few things here. I'll just get it. Okay, let's have this meta static. Let's guess this. Okay, common. I have this. I'll just paste it. This is one of the questions that I was checking out. What are the common side effects of systematic therapeutic agents? Okay, now this is a question that I feel that is then the document I want to retrieve and see if it's able to retrieve that. Now for that, what I'm going to do is docs equals db dot similarity similarity search. I'm going to use this function. So similarity search with score. It's not capital. It also gives you a score. So db dot similarity search with score, and I'm going to pass query equals query, and I'm going to pass top k documents for how many top k document you should retrieve. So I'm going to say then k equals 2. Only look at two top k documents, two documents. Now let's for that for I in docs, and here I'm going to say docs score equals I, and then I'm going to just print that, excuse me, and then print, and your then I'm going to print score equals score, and your content equals doc.page content, and then metadata. So metadata is doc.metadata. Perfect. Now this is going to be a function. Now let's run this, guys. Now this will help us retrieve and see if the LLM that, oh sorry, the embedding model that we have used has created the right set of embeddings, or this, or the quadrant is able to retrieve or not, for this particular query with the right result. So for that, you come here and do Python retriever.py. It says name doc is not defined. It says, do you mean docs? Now for docs. Ah, okay. This should not be docs. This will be doc. Okay. Now let's run this again. So for that, I'm gonna again run this Python retriever.py, and then we are expecting that it will be able to basically, retrieve that. And you can see we got a couple of answers here. Of course, the retriever with having the similarity score of around 55 to 60%. So the first one is around 60% of similarity score. Common side effects of oncology medications, it has myelosuppression, mucositis, alopsia, cardiac, the pronunciations are really complex, man. Renal neuropathy, liver rash, etc., etc. It gives you something here, then it has. Now you can find out the right answer is the second one, right? This is the right retrieved response. Now you can also do one thing, guys. You can use re-ranking method of LangChain or Coher if you want to use Coher. You can also do that. You can also do that with open source. You can also use long context reorder. Okay, that helps you. Let me show that. It's not rocket science. I've covered that in previous videos as well. I'll give the link in the description of that video. LangChain long context reorder. That's called re-ranking. You can use that as well. You can look at here. It has long lost in the middle, right? LLM has an issue with lost in the middle. It's a research done by Stanford where you have n number of retrieved paragraphs or chunks. LLM ignores everything which in the middle. It only looks at the first and the last. So keep these things in mind, which helps you build better RAGs. Okay. Now you can use that. You can find it out here. Let me show that. You have this long context reorder. You can see this here, right? Now this is important. It also helps you transform. So you can use that here. I'm keeping this right now as void. You can use it in your experimentation. I'll give the link of the video that I created earlier, the merge ranker and etc. You can use that, and also give you this one as well. Anyway, let's go back to our exercise now for this here. And you can see we are able to retrieve now. So the retriever is working. You can find it out. This is the right response. This is fine. Now let's create one more file here quickly. Let's create two folders first, static, and then one folder as templates. In templates, I'm going to create an index HTML. So let's do that. So I'm going to create index.html, and I'm not going to write a single line of code here. Or of course, to write a single line, you have to change the name by the way, but I'll show you why I'm talking. I'll go back here and I'll go to my investment banker chatbot, the previous video where I created a RAG again for a chatbot, for a QA app for using Intel's neural chat, Intel's new large language model. Maybe you can also check that out. Now here I'm going to copy this. I'm going to open this templates, index HTML. I'm going to just copy this thing here. Come here because let's keep the same thing. Design, fine. Design, fine. uh, now let's do an Alt G so I can change a few things. Now let me just change that here. It says investment banking chatbot. Let's call that this as Medical RAG QA app. Now this is fine. Now let's about this app. This is RAG implementation using open source stacks. Uh, Meditron 7B has been used to build this app along with PubMedBERT base. PubMed, what was that? PubMedBERT base, yes. BERT base as an embedding model. QDRAND as to QDRAND as a vector store, a vector database, by the way. It's a database, okay. And LangChain and these are fine. Now, so we are okay with this. And I'm going to go back here again in the fast API. Let's go to fast API app thingy and copy these two. Come here and let's create a file called rag.py where we're going to write our file. In rag.py, I'm going to copy this, paste this. Okay, it's py. Okay, and let's keep. I'm not going to make any changes in this function. These are all fine. Let me just do an Alt G so you can see it. And I'll also copy a lot of things here. Let's copy this entire thing. Why not? Okay, because we're going to use the same thing again. I'll explain that. Now, what we are doing is, if you look at here, we are basically using prompt template. We don't need chroma, so let me just remove chroma from here. We don't need this entire thing. Okay, we don't need Hugging Face BGE. We don't need PyPDF. We do not need these two. Okay, now let's go to retriever and copy what we need. We need all of these three here. Okay, so let's copy, come here, paste it down. Perfect. Now let me explain what we are doing. So we are using a fast API, which is a Python library to build backend services that like microservices, APIs, etc. You can also build, you can also integrate that with front end through Jinja 2, etc. as well. Now, it's a joy to work with fast API. It's scalable, it's fast, it's asynchronous, etc. Now we have a templates. We are using Jinja 2 templates. We have defined a directory which is your templates. If you have some other name, you have to change that here. Then we have a static where you can keep your logo, CSS file, etc. Where you're not going to change that file. That's the static. I have mounted that. Then we have a local LLM. We're using neural chat. So we do not have to use neural chat. We have to use Meditron here. So let's make that change. So Meditron, and from where you will download that LLM, find the link in the description. We're going to download it from the blog again, Tom Jobbins on Hugging Face. We're going to download the model from there. So Meditron 7B and 7b dot q, what is that? Q4 underscore, K underscore M underscore, not underscore, GGUF. This is the model, GGUF model. Unified format for generalized machine learning. It's fantastic. Earlier we used to use ggml, right? Now we're using gguf, if you don't know. Okay, now config. And what you can also do, guys, some of you might face errors with context tokens. Okay, like if you are exceeding context tokens. Now let me just do a context length here. So context length, for example, I'll keep it 2048 and we'll see 2048 as context length. Then we have penalties, etc. Then we have C transformers, for CPU use. This all looks nice. Here you're not going to write a Mistral. It's a Llama model. Keep in mind that Meditron is a Llama based model. So you have to change the name here in the model type. The local LLM is fine. The configs are fine, where you have the new tokens and all of those things are fine. Let me just max new token a bit smaller. So, we don't have to, some 512, so we get it quickly. The print is fine, the prompt template is fine, the model name, we do not need this model, we don't need BGE embeddings, we need our embedding. So let's get that from retriever. Let's just copy the entire thing here, the data and DB, everything. Okay, now I'm going to copy this here, come here in the RAG thing, paste it over there. Now we have a sentence transformer embeddings class where we are using the model name, which is PubMedBERT based embeddings. Now we are running on the URL, which is running inside a Docker container. Then we have a QDrent client again, the class of QDrent clients. We create a client here that we can use it. You can see client equals client. We are passing a DB thing here. Now, if you look at what interesting that we are doing here is, guys, we are not using Chroma or FAS or vector store. We are using a vector database which has been self-hosted and running inside a Docker container. Now, we have our prompt templates, context question. You can chain the templates. You have to write a better prompt, to be honest, if you are trying to do something in production. This is very simple, not recommended. Now, you can do a role based prompting, instructions based prompting, chain of thoughts, etc. Now, you have a prompt template. We don't need this, guys, now load vector store, because we're already using it through client. So let's remove that load vector store thing. Now we need the retriever. So in the retriever, what I'm going to make a change here is, I'm not going to use load vector store. Now this will get changed you with db. So we're going to use db instead load vector store, because db is the variable which has your queued rand thing. Okay, now db, excuse me, and I'm only looking at top k is equal to one document, but again you can increase this as well. You can keep top k equals to 2 3 depending on the context length windows, etc. You can do that. Now the retriever is fine, and if you come here, we have a redirect thing which basically gives you index.html. It will load a wave UI kind of a thing. I will show that in a bit, and this is the function that does that. Now we have this main function which is your async def get response. This is an endpoint which is the get response, and then we have a query where you have the prompt chain type quarks prompt. Then you have a QA retrieval QA from chain time. So we're using retrieval QA. We have different types of QA. And if you want to use the new LangChain expression language, LCEL, watch the video again. I have a detailed video of LCEL. So it has a different way of defining things, the chains, etc. in LCEL, but this is the old one. Now retrieval QA from chain type LLMs equals LLM. You can see that we are using this LLM in the C transformers. Chain type stuff, you can use map, re-rank, refine depending on the use cases. For summarization, you will look at refine, map, re-rank when you have some relationship between your responses, or different type of chain type. Now retriever equals to retriever. We have our return source documents from metadata. It's coming. If you look at the metadata in QDrand. Now chain type quarks, basically it's a prompt thingy that we have somewhere here. And then verbose equals to true, it will show in the terminal. Okay, like entering retrieval QA chain, etc. If you keep it false, you will not be able to track it. That's all, guys. Now let's run this and see if we get any error first. Okay, so not Python, you run this using, you can run it with Python as well. You have to define that below in the main function, def main or something. Now Python rag is the file name, and then your app name, so rag app. You can see it says LLM initialized. Okay, and I will open this, and you can see, let me just close this. You can see we have our vector database running over here, which is fine. Now let's open localhost 8000. Now once I open localhost 8000, you will see an interface here, a wave UI. It says Medical RAG QA app. About this app, if you click on an accordion, which is a collapsible accordion, it says this is a RAG implementation using open source stack. Meditron 7B has been used to build this app along with PubMedBERT base. Again, both the embedding model and the LLM both are medical specific, so they might perform better. If you are facing or struggling with RAG for medical or healthcare, you should look at this as well. Of course, with different techniques that I shown in the middle, like for example, re-ranking, the long context reorder. You can also look at those things as well. Now, QDrand as a vector database and LangChain and C transform. Let's ask this question. So what I'm going to do is I'm going to ask this question, metastatic disease or something. So I'm going to say, okay, what is metastatic disease? And once I click on processing, now I'm expecting that it will go inside a retrieval QA chain. You can see it says entering new retrieval QA chain. It enters into the new retrieval QA chain and looks at the retrieved response from the vector database, which is running here on QDrand, vector database. Once the retrieved chunks has been successfully retrieved by the retriever, that has been that has been fed to the large language model Meditron with your prompt template. So the prompt that you have, and that contains your questions and your context. If you look at the prompt template here, now for each query that you put in the input box of that interface, these two variables will also get passed to it with your templates, and then we are expecting that we get some answer here. You can see it's running it takes around 40 to 45 seconds at an average on to run it on a 16 GB CPU machine. If you have GPU, you can define in GPU layers and you can pass that as well, GPU layers. Now, so this is the LLM guys here. You can find it out on Hugging Face. This is the embedding model. Both links will be in the description. You can go through that. Now you can see that we have our response here, and the reason I'm showing you that I'm not happy with this model is because it does not work really good for rags. If you ask general purpose questions, it might gives you, but if you look at the question that I asked, what is metastatic disease, it says diagnosed by biopsy or cytology that shows status or from melanoma. Metastasis include but it's not limited to the first cancer, something like that. So it gives you the response, but if you look at the question again, it says what is BRF mutation. Okay, so it's asking question within the question, so it's not looking at probably your, it's not generalizing well on the embeddings that we have created. Once it has been fed with the retrieved document or the chunks, it's not able to interpret that. Okay, now you can find it out here. Let me ask the other question. What was the other question that we asked? Okay, what are the common side effects of systematic systematic therapeutic agents? I don't know if I'm pronouncing it right, but whatever it is. Okay, so let's wait for this. And if you come to Meditron here on the Hugging Face repository, you can find out, it's a, of course, it's a causal model for text generation. If you come down, I was wanted to show you something here that I was reading. They say the use cases can be this. Potential use cases may include medical exam question answering, supporting differential diagnosis, disease information, symptoms, cause, treatment query, and general health information query. But don't I, I don't recommend this at this moment to use this in any kind of use cases, because I have tried working with few use cases and I was not happy with the performance of this model. But as an open source model, as an open source community, we always have to give credit to the creators because they have put the efforts to create these LLMs, and this is just the beginning, right? So credit goes to them for building this, but don't use this in production. I'll be very blunt. You do not use this in production. You can look at over here. Somewhere they would have said that as well. If I'm not wrong. Okay, I don't know where is that, but if you look at here, it has performed well on the leaderboard for this, particularly for this data set. For this data set it has performed well, but I am not a big fan of this evaluation benchmarks. You can start putting, you can use this same data set, put this in your model when you are training it, right? So it already has seen the training corpus. The real test is when you ask unseen questions, because these are available, right? You can put that in the training corpus, train it again when you are training it, so it's fine. Now, if I ask this question, you can see in my clinical practice, so it's somebody else's answer. So it has seen that while training. I don't know if they have worked on the PII or the deduplications, etc. On the training steps on that context. Now, if you look at here, it says, in my clinical practice, I have seen the following common side effects of oncology medications. It gives you, and this is the right response because this has been retrieved. You can look at the myelosuppressions, or I don't know, carboplatin, etc. You can find it out over here. The same thing. So this is the right response that we got. This is the right answer that we have retrieved, guys. Let's ask one question probably from the that other document that we have, because I've been asking from the same questions. Now I'm going to open medrag data. Can we ask from this question, this from something here? What can we ask from here, guys? Let me see that. Uh, to Let me ask this: avoiding immune deconstruction. So I'm asking this question: what do we mean by? So what do we mean by avoiding immune deconstruction? Let me ask this question and see if it's able to get it. Okay, now I'm asking this question. I will take a bit. This is the last question that we're gonna use, in this exercise. But this is good. As a 7B model, I don't know. I mean, the Llama 2 7B chat, Llama 2 7B chat was the most stable model I have seen when it comes to 7B variant. You know, even I didn't rate Jaifer or Jafer as that much as well. Now, Mistral was a bit better. But they have higher tendency of hallucinations. If you look at Vectra's hallucination leaderboard, you will find it out what I'm talking. The Mistrals and the Llama, the Jaifer, sorry. Llama is very good when it comes to hallucination rate. They are even better than some closed source models like Cloudy by Anthropic and Coher. Llama has performed better than them, when it comes to hallucination rates. Now, let's see what answer we get it for this question. So, okay, and you can see it says immune deconstruction is a process uh, whereby the immune system attacks cells which it thinks are harming it. Or let me make it bigger so you can also read it, guys. It says immune deconstruction is a process whereby the immune system attacks cells which it thinks are harming it or diseased, for example, cancerous cells. Please check only the above. Please don't give an answer if you don't if you do not know the answer to this question. Also, if someone wants further info, he should get into his info from Wikipedia on. Thank you very much. End of the answer section. Go back to the top. This is rubbish. This is rubbish. I don't know. Maybe through some prompt instructions you can improve this, but this is pathetic. We got the context. Our retriever is working perfectly fine. So I'm very happy with this embedding model, PubMedBERT based embeddings, and the way our CUDA and vector database is working. So at that part, it's working completely fine. But I'm not happy with the Meditron 7B LLM, and you can see the results. Maybe you can do something else. Please let me know. Your thoughts or findings or feedbacks on Meditron. In the comment box. You can also reach out to me through my social media channels. Now, uh, the code will be available on the GitHub repository, guys. You can find it out the entire app on my GitHub repo. I'll give the link in the description. And this is what I wanted to create in this video. I wanted to cover Meditron and see the performances and give my genuine feedback. And we also saw a new embedding, not it's not a new embedding model, but it's a new for us while building RAG, because we have been using BGE embedding, sentence transformers, OpenAI embeddings, Vertex AI embeddings, etc., etc. Now we also looked at QDRANT, and I hope you learned something on how to use a self-hosted vector database with an embedding model through sentence transformer class, and how to build a RAG, a domain-specific RAG. Now, if you like the content, if you like the channel, please hit the like icon for this video, and also please subscribe the channel if you haven't subscribed the channel yet. You have a lot of videos on different Gen AI topics. Please find that in different playlist. That's all for this video, guys. Thank you so much for watching. See you in the next one.